Hi, Bio54 students. My name is Jeff Dominici, and I did my master's topic on stem cells. Before I get started on my presentation, I'm going to give you a brief outline so you know what to expect. I'm going to give you a brief background on stem cells, some applications of the technology, a subset of stem cell research, which is treating diabetes, some of the limitations surrounding stem cells, and conclude a conclusion, giving you kind of a brief indication of the future of stem cells. What are stem cells? If you were to Google what is a stem cell, you would get a lot of results. But in the most basic of terms, a stem cell is a blank slate. It isn't any specific cell filling any specific role. There are approximately 200 known different types of stem cells, but there are two really popular types, the ones that you'll hear most often, and those referred to as adult stem cells and embryonic stem cells. So similar to what their names kind of make them sound like, adult stem cells are found in the body. They're already in your body as you're developing. They're found in the heart, various tissues, of course all the organs like the heart, and the most controversial is the embryonic stem cell, and that is found in the embryo. How do they work? So, like I said, stem cells are a blank slate. Under the right conditions, given the right chemical formula, a stem cell will differentiate itself into another type of cell, a specialized cell. And in that little diagram off to the right, you can see you start out with a little cell and it separates or differentiates into what they call a mature cell, but this could actually be a heart cell, or it could be a alpha beta insulin producing cell, which is what you want to treat diabetes. So the applications of stem cells are sky's the limit. Stem cells can treat any disease or disorder anywhere that there's damaged tissue or cells. And where this actually has a lot of room for development is right now, if you needed an organ transplant, let's just say, you would be on a long list. And there's a good chance you might not get it, and as a result, your health could seriously suffer or you could lose your life. And this is where stem cells can step in, and where doctors and biochemists can engineer a stem cell for a patient-specific cure or treatment to treat whatever might ail you. And there are many treatments that could be developed through stem cells, and just to name a few were macular degeneration, spinal injuries, heart disease, and osteoarthritis. The reason I chose stem cells is because I knew that they could treat spinal injuries. And I was injured in a motorcycle accident, and they wanted to do a minor operation on my back because I had some issues that were causing me prolonged pain, and I didn't want to take any medication. And one of the things that the doctor said is, well, not right now, but they're doing research, and eventually, probably in your lifetime, there'll be a stem cell treatment for your ailment. Well, I really do hope they get that. So the subset topic that I'm going to be talking about is using stem cells to treat diabetes. I know that there's another individual that is doing his presentation on diabetes, so I'm not going to spend a lot of time on it. But diabetes affects approximately 5% of the world's population. This is hundreds of millions of people. And as a result, there is a need to develop not just a treatment, but a cure. And that's what a lot of these drugs that are currently out on the market, they're treatments. They mask the issue. They don't cure the issue. Through stem cells, they might be able to develop a cure to where the human body is actually now generating its own stem cells. It's not as easy though as just throwing in a few stem cells and just heating them up and they make the right type of cell. It's complicated. There's two different types of diabetes. There's type 1 and type 2. In type 1, in the most basic sense, the body's immune system is attacking and killing the insulin producing cells. These are known as beta cells. In type 2, this is generally developed a little bit over time, and it is as a result of decreased insulin selectivity in the tissue, and the overall effectiveness of the insulin producing cells decreases. And when these two factors combine, you now become what they call a diabetic. So treating stem cells or using stem cells to treat diabetes, There are many different approaches. If you look up research, there are hundreds of different research articles using all forms of different stem cells, but there's a common trend. Researchers are either using an adult stem cell for treatment or an embryonic stem cell. So adult stem cells, in most of the research, are found in from either an organ like a heart or the pancreas, or in this case, a lot of the research that I did was on bone marrow. And the reason that they did bone marrow is that you could use bone marrow from the actual human body or the patient's body, and you can take that cell, transform it into an insulin producing beta cell. There's about a 3-step process. You don't just take a bone marrow or a stem cell from bone marrow and turn it into an insulin producing beta cell, but it can be used as the foundation to actually use the patient's cells to make a insulin producing cell. They also found that using adult stem cells found in the patient's body promoted regeneration of the insulin producing beta cell. And it did another thing too, is they found that when using a stem cell from the patient's body that there was less rejection by the immune system. And I guess that's a big concern, that if you do a treatment or you do some sort of transfusion of blood and the human body rejects it and destroys it, then it defeated the purpose of doing it. And that's what you're seeing in type 1 diabetes, where the immune system attacks those beta cells, and so you need to keep them alive. They found in studies that in giving stem cells, adult stem cells, to mice that were diabetic, they found that actually their levels came down and they came to an almost homeostasis level where you couldn't tell that they were diabetic. Embryonic stem cells are another form of stem cell technology that's being used to treat diabetes and other diseases. The best thing about embryonic stem cells is their origin. They're not an adult stem cell. They're from about a 4-day-old embryo, and as a result, they're easier to differentiate. And what that means is they're easier to transform into another cell, whatever that cell might be. And in this case, we wanted to turn into an insulin-producing beta cell. They were successful in making beta cells. And again, like the similar treatments with the adult stem cells in diabetic mice, they did the same thing in diabetic mice using embryonic stem cells to make beta cells, and they found that it lowered the glucose level. And so there was a lot of potential. Limitations. There are currently some severe limitations revolving around the implementation of stem cell technology, and it's broad across all fields, whether it's using it to treat cancer, using it to create a new organ. And we'll start with adult stem cells. So with an adult stem cell, they're hard to take that adult stem cell and transform it into another cell or a specialized cell. It takes a little bit more engineering. There's reduced generation of tissue, so as it's regenerating itself or splitting, it doesn't necessarily want to make the type of cell that you want. And again, that gets into, it's hard to just produce the cell that you want. And then again, because of these difficulties, it's hard to scale up. So in a lab, it's easy to make a few or have a few adult stem cells and use them, but to scale up into a mass production quantity, it's very difficult. Then that leads us to embryonic stem cells. Just the name alone is controversial. Right now, usually scientists go to an in vitro clinic and take the embryonic stem cells from a 4-day-old embryo. Depending on how you feel on the topic, that results in the destruction of the embryo, and that has some ethical issues. Also, scale up is another factor. You need to make a lot of stem cells to produce the specific type of cell that you need or tissue, and that takes a lot of time and money. Another issue is when they found implementing embryonic stem cells in mice, for instance, that the cells don't necessarily behave the way you want them to. So you see some initial results and it says, okay, great. But what they found is in certain subjects, they create tumors. And these masses would start to grow where the cells just weren't turning into, the stem cells weren't turning into what you wanted them to be. In addition to that, they found with both stem cells that in the event that you need insulin to treat the diabetes or your blood, you need to regulate the blood sugar, they were slower to respond. And through these limitations, at least researchers know what they need to work on for the future of the technology. Conclusion. Stem cells, as I said before, sky's the limit. You have the ability to treat almost every disease known to man. They're patient-specific, meaning you can take the stem cells from the human or the patient's test subject, and you can create a treatment just for them. And it doesn't treat them, it can actually cure them. It's not a band-aid, it's a cure. This has the ability to save countless lives. And of course, it's lucrative. There's a lot of money to be made, and the reason I had a biology textbook there is if you are the one to develop stem cell technology and you cure a disease, you cure cancer, your name is going to be in that textbook. Thank you.